Hi, this is for one of my students. He is doing module 3, I believe, sections 1 through 7, and want to do some corrections on this. So, hope you're ready. Starts with the letter E. All right. So, anyways, I was going through your stuff and I started to see some issues. So, please try to follow directions when they ask for directions. Number one. Um, It says for 3.3 ready portion, it says circle the point of intersection. So I noticed that you didn't do that. So how do I find the point of intersection? For number one, it's going to be at 3, 4. These are the points of intersection, right? So when you plug in 3, f of 3 has to equal 4, correct? My input is 3, my output is 4. G function of 3 also has to equal 4 as well, right? Because 3 plus 1 is also 4. So make sure you circle those, all right, for all of them. The next one was, this is not your domain on the part of Go. The domain is from starts at -4 and goes up to 0. So it's bracket -4 to 0, bracket because it includes that point, union, and it includes starting at 1 to 3 bracket as well. Okay, so it goes from -4 to 0 inclusive, and then from 1 to 3, and then from 4 to 5 as well. Union bracket because it includes 4 and 5. Let me write that again. 4 to 5. Okay, and bracket. Okay, so make sure you do those correctly. Next one right there, the domain for this function. It seems to be that there's an asymptote at 6, but it's not. It seems to be passing it, right? Passing it this way. So the domain has to be probably negative infinity to positive infinity. The only time that you have a asymptote that looks like it is something like this one right here, number 9, where it's like approaching it but never touching it. That would be kind of like girls for high school, right? You can get close as you want, but you can't touch them. For this one right over here, this one was wrong. So the range, it starts off at -1 and goes to negative infinity. So negative infinity is fine, but at -1, it should be a bracket right there. All right. The domain is your x value, right? On 3.7. So the way we do that is the domain is a set such that it's -7, 3, 8, -6, and -2. That's your domain. Your range of value that comes out is going to be your y value, which is 2, 5, 4, 5, and 3. And 3. Those are your range of values, okay? I checked all of them. It seems to be correct. So make sure when you print your domain, your range, it's not just -7 up to 8, because it doesn't include like -6.5, okay? Same as this as well. This one, this is kind of tricky. So for most of it, you did right, except for some of them, okay? So let's go through explicit and recursive formula. I believe the explicit for linear functions are correct. Let's do this one right here. Oh, by the way, on the recursive, on this one right here, for every single one of them, you have to give a starting value. Starting value for this would be f of 3 equals 8. Okay, and then you can name this. You could also say the next function, the next number is equal to the previous number, x minus 1. And then instead of dividing by 2, I like to put a 1/2 in the front. Okay, it's just a notation preference. You don't want to say b times 2. You say 2 times b, or just 2b, right? So you don't want to say b2, you want to say 2b. Okay, so it's 1/2. You always put the coefficient in front. For the explicit function of this exponential graph, it's a little bit tricky. The standard form is f of x is equal to a times b to the x power, right? Where this is your starting value when my input or my x value is 0. Okay, that's your starting value. Because what's any number to the 0 power? That's going to be 1, right? So we start off at 3. We have to put 2 here. When it's 2, it's going to be 16. When it's 1, it's going to be 32. And when it's 0, it's going to be 64. So it's actually the explicit function for this right there. It's going to look like this. F of x is equal to 64 times 1/2 to the x power. Okay, so that's it. It's about 6 minutes long. Hope you enjoyed it and hope you learned from it. And some of these you want to fix, like I believe this one right here, number 13, is not quite correct. Okay, and that's it. Good luck on your exam.